Mystery in the Ozone Layer, presented by Science at NASA. High above Earth, more than 20 miles above sea level, a diaphanous layer of ozone surrounds our planet, absorbing energetic UV rays from the sun. It is essentially sunscreen for planet Earth. Without the ozone layer, we would be bathed in dangerous radiation on a daily basis, with side effects ranging from cataracts to cancer. People were understandably alarmed then in the 1980s when scientists noticed that man-made chemicals in the atmosphere were destroying this layer. Governments quickly enacted an international treaty called the Montreal Protocol to ban ozone-destroying gases such as CFCs, then found, for example, in aerosol cans and air conditioners. On September 16, 1987, the first 24 nations signed the treaty. 173 more have signed on in the years since. Fast forward 27 years. Ozone-depleting chemicals have declined, and the ozone hole appears to be on the mend. The United Nations has called the Montreal Protocol the most successful treaty in UN history. Yet despite Montreal's success, something is not quite right. A new study by NASA researchers showed that a key ozone-depleting compound named carbon tetrachloride, or CCl4, is surprisingly more abundant in the ozone layer than it should be. We are not supposed to be seeing this at all, says NASA atmospheric scientist Xing Liang. Between 2007 and 2012, countries around the world reported zero emissions of CCl4. Yet measurements by satellites, weather balloons, aircraft, and surface-based sensors tell a different story. A study led by Liang shows worldwide emissions of CCl4 average 39 kilotons per year, approximately 30% of peak emissions prior to the international treaty going into effect. In the 1980s, chlorofluorocarbons became well known to the general public. As the ozone hole widened, CFC became a household word. Fewer people, however, have heard of CCl4, once used in applications such as dry cleaning and fire extinguishers. Nevertheless, says Liang, CCl4 is a major ozone-depleting substance. It is the third most important anthropogenic ozone-depleting compound behind CFC11 and CFC12. Levels of CCl4 have been declining since the Montreal Protocol was signed, just not as rapidly as expected. With zero emissions, abundances should have dropped by 4% per year. Instead, the decline has been closer to 1% per year. To investigate the discrepancy, Liang and colleagues took CCl4 data gathered by NOAA and NASA and plugged it into a NASA computer program, the 3D GEOS Chemistry Climate Model. This sophisticated program takes into account the way CCl4 is broken apart by solar radiation in the stratosphere, as well as how the compound can be absorbed and degraded by contact with soil and ocean waters. Model simulations pointed to an unidentified ongoing current source of CCl4. It is now apparent that there are either unidentified industrial leakages, large emissions from contaminated sites, or unknown CCl4 sources, says Liang. Another possibility is that the chemistry of CCl4 might not be fully understood. Tellingly, the model showed that CCl4 is lingering in the atmosphere 40% longer than previously thought. Is there something about the physical CCl4 loss process that we don't understand, she wonders? It all adds up to a mystery in the ozone layer. Liang's research was published online in the August 18th issue of Geophysical Research Letters. More information about the extra CCl4 may be found there. For more science mysteries, on Earth and beyond, stay tuned to science.nasa.gov.